Okay, here's some more problems from 9.4. This is number 35. And I was going to use a ratio test on this one. I didn't say anything else that kind of caught my fancy. And the ratio test is always a nice safe one. I think I use that on a lot of these. And these are always positive, so I don't have to worry about absolute values. And I can rewrite this. This was my series as n squared over e to the n. And this looks a little bit, doesn't look like a geometric series. So we'll take the limit, and then we'll just take the n plus 1. So every time I see an n, I put n plus 1 squared over e to the n plus 1 times e to the n, which is the reciprocal over n squared. So that's basically your ratio test. I think I skipped some steps on that one. I didn't really write it out, but you know what it is. And then we could take a look at this, and this I left this the same, and then this is going to be e to the n times e, that's e to the n plus 1, and there's your e to the n, and there's your n squared, and these e's will cancel, e to the n's will cancel. So I'm going to have 1 over e, and then I've got my n squared, n plus 1 squared over n. Now what I do is I multiply this out. So I got n squared plus 2n plus 1, all over n squared, and then I put the 1 over e over here. All right? So if you can see this, all right? Now, what's the limit as n approaches infinity of all this on the left? Well, again, if I look at, it's a rational expression, if I look at in their polynomials, if I look at the highest degree term, if I look at the coefficients, the ratio of the coefficients of the highest degree terms is 1 over 1, so the limit is 1. So it's just going to be equal to 1 over e, and 1 over e, that's L. And L is less than 1 because 1 over e is less than 1. He's about 2.7, so it's like 1/3 less than 1, so it converges because L is less than 1. Okay, 36. Again, it's positive. N to the 10th over 10 to the n. So we use the ratio test. There's our, I wrote it out this time. So n plus 1 to the 10 over 10 to the n plus 1, and then times the reciprocal 10 to the n over n to the 10th. And then we can break this up, 10 to the n. So you can cancel those out eventually. And that's about all we could do, all we have to do there. So those are canceled, so I end up with 1/10. And then I have n plus 1 to the 10th over n to the 10th. Now, if I multiply this out, all these times, my highest degree term would be 10. So, again, I would have the same ratio, 1 over 1. So that limit would be 1. If you didn't want to think about that, oh boy, you could say that as n approaches infinity, this would become so big. Compared to that, I could just kick the caboodle like Cal says. So we just have n to the 10th over n to the 10th. And I could say that's n over n to the 10th, which is just 1 to the 10th, which is 1. There's lots of ways of dealing with it. Or infinity over infinity, which is 1. So anyway, that's going to be 1. So I'm going to have 1 times 1/10 is 1/10, and that's less than 1, so it converges. Remember, that's our L. Okay, and then number 37, we also use a ratio test for here. Probably pretty safe on that ratio test because, the only time it works, is when it's equal to 1, then you have to try something else. But when in doubt, if nothing else is really obvious, it's not obviously a geometric series or an nth term going to non-zero, then try the ratio test. Okay, so we have n plus 3 factorial over 3 factorial, n factorial, 3 to the n. So this is my n plus 1. So every time I see an n, I put n plus 1. So n plus 1 plus 3 is n plus 4. 3 factorial, n plus 1 factorial, 3 to the n plus 1 factorial. And then I've got over here inverted multiply, 3 factorial, n factorial, 3 to the n, all over 3 plus n plus 3 factorial. Boy. All right. I took all my n's and numbers. Well, first of all, yeah, this was the inverse. So I reciprocated that, so I put it over there. Put the reciprocal that over there. Okay, so wrote it all out, and I put Now, our n plus 4 factorial is the same thing as n plus 4 times n plus 3 times n plus 2. So it's the same thing as n plus 4 times n plus 3 factorial. So I could write it out like this. Okay? This is 3 factorial. This is n plus 1 factorial, which is like n plus 1 times n factorial. See, n plus 1 times n minus 1 times n minus 2. So I could write that as n plus 1 times n factorial. And then I could write the 3 to the n plus 1 as 3 times 3 to the n. And then I could pretty much write this out as is. Now look at all the things that cancel now that I wrote this out. The n plus 3 factorials cancel. The 3 factorials cancel. 3 to the n's cancel. So what am I left with? I'm left with n plus 4 on the top and 3 on the bottom and an n plus 1. These canceled, all this other stuff canceled. Okay, so I just had left n plus 4, canceled, 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 3 factorial. Okay, and on the bottom I had 3, okay, and n plus 1. Okay, so if I just multiply this out, I have the limit as n approaches infinity of n plus 4 over 3 n plus 3. And again, I can look at the ratio of my highest degree terms. In this case, they're just n, and the ratio would be 1 over 3, so that's less than most of converges. Alrighty? Oh, I hope I didn't cut all this stuff. So take a look at this. Again, rewrote this. Okay, n plus 4 times n plus 3 factorial. And there's your 3, and all that stuff's over there. That didn't change. And on the bottom, this is 3 factorial. N plus 1 times n. I probably should have written them in the opposite order. Make a little bit more sense. And then 3 and 3n, and I've got all this over here, which is the same. That canceled. The 3 factorials canceled, and 3n canceled. So what's just left is n plus 4. Okay, everything else here canceled. And then 3, and then n plus 1. All these other things canceled. So that's all that's left. Okay, so does that make sense? And 38. Well, if I look at this limit, now this is probably something you have to remember. This was a limit we should know. The limit as n approaches infinity of 1 over 1 plus n to the n. Okay, if I let that be my nth term, if I take the limit as n approaches infinity, that just is equal to e. Okay, that's our definition of e actually. The limit as n approaches infinity of 1 over 1 of 1 plus 1 over n to the n. That's kind of like our compound interest formula. Okay, so it diverges by the nth term test because the limit is equal to e. Okay, 39. Negative to the n. I can put these both to the n power, and it looks like this is a geometric series because I got a common ratio, negative 2/3. That's my r. Since the absolute value of r is less than 1, it converges. Okay, and the last one, number 40. N factorial e to the negative n. So it looks like I'm going to use the ratio test on this one. So I'll rewrite that as n factorial over e to the n. They're all positive terms, so I don't have to worry about the absolute value. So I use the ratio test. That's this limit. So n plus 1 factorial over e to the n plus 1 times the reciprocal of this, which is e to the n over n factorial. Let's see what we've got. And again, I'll rewrite this as n factorial times n plus 1. Okay? And I can rewrite this e times e to the n over, and this is the inverse of that, so it's n e to the n over n factorial. The n factorial is canceled, these cancel, so I've got n plus 1 on the top, all times 1 over e. Well, if I take the limit as n approaches infinity, nothing's going to fix this up, so that's going to be infinity, which is greater than 1, so diverges. Okay? So that was a ratio test. You could also use the nth term test. If you look at the limit as n approaches infinity, you've got factorials over exponents. If you have n in a factorial and n is an exponent, okay, you can show that as this goes out to infinity, the numerator will outstrip the denominator, and the limit will be infinity. All right? Okay, because that's going to go to infinity faster than that. So that's going to be infinity. If that was in the bottom, it would be 0. If it took the inverse of that, or the reciprocal of that, it would be 0, because the factorial is always going to go to infinity faster than the power. So it also diverges by the nth term test. So that's another way to do it. Okay? All right, hope those help.